Okay, so the first question, let's do this one together. What is Kirchhoff's first law? Oops, it's the loop one, isn't it? Or is it the junction one? Well, it says it on page 52. Which does it say is first?
Junction rules.
Junction rules first. So what they want here is for A part 1 is to state it as a formula.
That,
Yeah, well not delta,
no,
sigma. Sigma junction, all the currents going into the junction, total 0.
You don't have to include volts.
No, that's the second law, isn't it? The first law is the junction one, isn't it?
Yes.
Yeah. Now, for the next part, they want you to explain or why is this true. Well, I've said it so many times. The charge that goes into a junction, or the total charge in, must equal the total charge out. Otherwise, you have charge that collects inside the junction, or otherwise you have charge that's being created. Alright, so if there's more charge going in than coming out, then what's happening? There's charge building in the inside. And if there's more charge leaving than going in, what's happening? Something's discharging, yeah, that there's charge coming into existence, yeah. So as a sentence, what could we say? We could say that current, or in other words, charge per second is conserved. Do you remember what the word conserved means? It means it doesn't change in total. Okay. Part 3. Kirchhoff's second law is the loop. Yeah, so the sum around a loop of all the voltages totals 0. Now, what is the reason for this? Like, the first one was because the charge must be constant. You can't make charge. What goes in comes out. So what's the reason for the total voltage being 0?
Conservation.
Very good. Conservation of energy. So what the battery provides must be used up by all the resistors around the circuit. So it's because of conservation of energy. That's the reason why. So for example, what the cell, sorry, so this is an example, what the cell provides in energy is used by the resistors. Um, 4 marks, and because each one is only 1 mark, you don't have to write much to get it. Okay? Right, so that's part A done. So that should be a straightforward 4 marks. If you didn't know how to explain it, you know how to write the rule down, so you should be getting at least 2 out of 4. What percent is 2 out of 4? 50, which is what grade? It's a C grade. Okay? Oh no, you're finished? Yeah. Okay, now let's look at the B one. Okay, so B. State and redraw the circuit showing the single resistors and their values that can replace the series and parallel resistor combination. So do you see where it says there the circuit showing single resistors and their values that can replace the series and parallel resistors. In other words, if you look at the diagram here, these two resistors, you can put them together, true?
Yeah.
And then these two resistors, you can put them together. These are in parallel and these are in series. So let's just add them together. So the first one, 1 over R equals 1 over 3 plus 1 over 6. So that is a half. Isn't it? No, it's not.
Yes.
It is a half, yeah. So therefore, R equals 2. And then the other one, you get R equals 2 plus 2. So therefore, for the other one, R equals 4. So if I redraw this now, there's a 4 resistor here. And there is a 8 resistor here. And there is a 2 resistor there. I know there's batteries as well that I need to draw in. Oops. So there's a battery here. There's a battery here. And there's a battery here. Okay. Anyways, they want to see these resistors, but I think they might want me to simplify it even more. So these can go together, and then these can go together. So
We can't.
But it's a different voltage.
yeah, but then it will change the current, which we probably don't need for the next part.
I think this.
I think they probably want you to stop here because if you there's different, as you said, there's different voltages, so it messes up trying to do the Kirchhoff part. Let's see what they did in the marking scheme, though. 482. Yeah. Okay, good. Not so bad. And how many marks for that?
5. You have to draw.
But they did say draw, yeah.
Yes.
No, okay. Now we want Kirchhoff. So let me add in the currents. So here is an I1. Here is an I2. They're going into that one is a 0.5 amp. This is 11 volts. This is E volts. Oh, and this is upside down, isn't it? And then this is 7 volts. Let me fix that one. It should be the other way. Okay, so we have.
No, it's not correct. It was correct. Yeah.
Oh, was correct.
Yeah, like that. Correct.
That's right. That's right, and that's right. Okay. Definitely use the junction rule here. So this is B part 1, B part 2 now. So part 1, now part 2. Okay, so the junction rule says the current going in, which is 0.5, minus I1 minus I2, that should equal 0. Now, I'll make, how many loops will I need to make? I just need 2. So let's take the 2 smallest loops. So if I go for this loop first, I have 11 plus or minus E. Minus E.
I know it's plus the same direction for now.
Well, it's minus here because the battery is against.
We will take E as plus.
Well, I suppose if we had the sign the wrong way around, it would just be the E would be the same number but a different sign at the end. So it actually doesn't matter too much in this case. 11 minus E minus 8 times 0.5. So that's 4. Minus 2 I2 equals 0. And then the last one, I'll loop around the left going up. E minus 4 minus 4I1. Now, plus or minus 7. Minus 7, isn't it? Because It's the battery's the wrong way around. Yeah, negative with negative.
Why
What's
did you
wrong?
go up?
Huh? Oh, you're right, I did. Well, it means all my signs are backwards, and because it equals 0, it shouldn't matter for the answer. But I'll do it the same as I was doing it yesterday, so we'll go around. Oh, but the current is going up, though. It really doesn't matter. Oh, wait. Let me take the outside one. I think that's easier because I don't have to have an E in the middle then. Yeah, so we'll start with the 11 this time. 11. Now, plus or minus? Minus 7. And then here, plus or minus? Ah, no. Plus 4i1. And then here, minus 2i2 equals 0. Okay.
Wouldn't it be easier to go down the middle because we will.
Yeah, you know,
We will not have two equations with I2, three equations with I2.
Yeah, but I'm going to use Gaussian block to solve this.
You don't have to.
I'm going to because I like it, and I did it yesterday in 4 minutes. Remember, we timed it. Yes? Now, I just want to clean these up before I solve them. I1 plus I2 equals 0.5. Yes? And then here, any I1s?
4i1.
No, for the next one, there's no I1s.
Yeah.
So it's just 2i2, yes? If I take everything to the right, plus E, 11 minus 4, 7 equals 7. Because I took the E and the 2i to the right. And then this one here, how many I1s?
2i1.
4 I1s, yeah, minus 2 I2s equals, now this here will be 4, but when I take it to the right, minus 4. So I'll put my block down. Oh, we'll go I1, I2 and E. Does this have an I1? Yes. Does this have an I2? Yes. Does this have an E? No. I have to swap these. So will the first one have an I1? Yes. Will the second one have an I2? Yes. Will the third one have an E? Yes. So putting in block form, 1, 1, 0, 0.5. And then here, any I1s here? Yeah. And look, this is the second one. Yeah. Any I1s? 4, minus 2, 0, minus 4. And then the last one, 0, 2, 1, 7. Okay. What should I multiply this by? 4. This one, 1. This one, 1. So I get 4, 4, 0, 2. 4 minus 2, 0, minus 4. 0, 2, 1, 7. Okay. What do I do here? Subtract, yep. So I get 4, 4, 0, 2, 0, 6, 0, 6. 0, 2, 1, 7. Okay, multiply again. Here, 1, here, 1, and here, 3. So, what do I get? 4, 4, 0, 2, 0, 6, 0, 6, 0, 6, 3, 21. And then here and here, yeah, subtract 4, 4, 0, 2, 0, 6, 0, 6, 0, 0, minus 3, and then 6 minus 21. Minus 15? Yeah. And it's finished. The last equation is minus 3e equals minus 15. So therefore, e equals 5. And we said we thought it should be smaller than the other batteries. Now, I put that in here. Oh, I don't even need to put it in, actually, because this one here is 6i2 equals 6. So therefore, I2 equals 1. And I can put them into the first one. 4i1 plus 4i2 plus 0 equals 2. So therefore, 2 minus 4
Minus 2.
is minus 2, divided by 4.
Minus 1
Yeah, it's minus a half, isn't it?
and 2.
Minus a half. Volts, amps, amps. They're the three answers. How many marks for that? How many marks for these three answers? Look at the marking scheme of the exam.
8,
8 marks. 8 marks. Let's just check if that's right. 5, 1, and minus 0.5. Not so bad, is it? Yeah. Now let's look at the last part.
Not that bad.
Sorry, the last two parts. What is the electric charge that flows between B and A? So that's up the center. Yeah, so in 2 minutes, how much charge flows? Well, we have our formula for that. What's our formula for charge with time? Q equals IVT. Do we know the I? We do. Do we know the V?
Yeah.
Do we?
Yeah, E. 4 from 5.
No, but it won't be E going through the resistor because the resistor doesn't use up all of the E. So we might have to, hey, we'll just use Ohm's law. What's Ohm's law for V? I or. So we'll just put another I. What's the or? 8. And what's the T? 120. It's 2 minutes, isn't it? Alright, so type that in, please. What do we get? This will be 240? 240 coulombs. Let's quick check. No.
Why did they use the time equals to 60?
They did. It's the wrong numbers here, isn't it?
Yeah, they multiply.
Oh, Q equals IT.
Yeah, but it's still wrong. The number is still wrong.
No, numbers are right. It's
No,
eight.
you're right. Because they said 2 minutes.
Hang on. This isn't the form. The formula for Q is IT, isn't it?
Yes.
Yeah. So we. Who said IVT? Isn't it Q equals IT?
Yes.
Yes, of course it is. Q equals IT.
They wrote 60.
But they still wrote the wrong time anyway, so we wouldn't have gotten the number matching up. What's the I?
No, 0.5 times 120
Yeah.
is 60.
The time is 2 times 60.
They had 2 times 60.
They did?
Yeah.
Well, I'll check it now. The I is 0.5 and the time is 120, which equals. Yeah, no, but where is it here?
2 times 60.
Yeah,
Yeah, but
2 minutes.
2 minutes times 60 seconds. That's 120 times.
yeah, no, but that's the I. Oh, yeah. They now I see it. Sorry, 2 minutes of 60 seconds. Yeah, they wrote the time as 2 times 60 instead of just 120. Okay. Right. That's fine. Q equals IT. Coulombs. Yeah. All right, and the last part. Oh well, the last part now is to calculate the voltage, which we already did. So using Ohm's law, what's voltage? V equals I or. I is 0.5 and or is 8. So we get 4.
They wanted to prove a known formula.
It was like 5 between
Oh, between B and A. So they also want the battery as well. No problem. So if I draw this now, this one here is 4, and then what was the battery, the E? 5, so then the total 9.
Why is it I?
Let's see. True B. Okay, let me just think about this. I need to visualize it. No. Let's just look at the diagram. So if we have our voltmeter and we connect it from B to A, it's calculating how much voltage was changed between B and A. Okay, so let's imagine here this current isn't going up, but it's going the wrong way through the battery, isn't it? So what happens when you go the wrong way through a battery? Do you add or decrease your voltage? You decrease. So you decrease by E. Yes? What is E? 5. And then when you go through a resistor, what happens to your voltage?
You again decrease.
You get decrease. So it decreases in both cases. Now, if this battery was flipped around, though, then you would subtract the two, yeah. And that is important, okay? So the reason for adding is because we're getting the total reduction. Both cause a reduction in the voltage. Reduction by E and then a reduction by whatever we worked out here for this one. 4. So a 5 and a 4 reduction. But like I said, if the battery is the other way around, then what would be the answer? 1. Okay. Okay, so there was a couple of small things to take care of it, but really it's not too bad. Right? So let's look at the next year then. So that's 2012. So let's see 2011 then, if you have it.
Which page?
Section B of 2011 starts at page 40. Number 1 looks like it. Yeah, so page 40. If you have it, please go to page 40.
Did you do the
We did, yeah.